So this is lesson 7-6, rational exponents, and it's going to seem a little strange watching this video because I actually recorded the video and turns out that there's no sound on it. And when I realized that, I no longer have access to the video, and so now I have to try to figure out how to record sound over a video that's already there. So I'm just playing the YouTube video and adding sound to it. So write this down as your title page and then update your table of contents. And here are your key concepts to copy down. Copy down anything that is highlighted. And as you'll notice, actually, we've done some of this before. And so it'll be kind of a review, but also bringing in some new concepts to go with it. And we're looking at an exponent that is a fraction can also be written as a radical. So copy the highlighted information down into your notebook. Okay, here's our first example. Write a to the 1/7 in radical form. And so if you look back at our rules, we can see that a fractional exponent of 1/7, the 7, which is a denominator, will go out in front, and the 1 is an exponent of a. And so we can just write it like that, or we really don't need that 1, so we can just write it as a 7th root of a. Okay, here's our second example. Write the square root of w in an exponential form. So we need to write it as an exponent. So we have to remember a square root. What would be that number inside of the radical symbol up there? So that would be a 2 up there. And so what we need to do is we need to write it as w raised to, the exponent is 1, so it's 1 over 2. That's how we write it in exponential form. All right, our next example. So this time we're going to have a negative exponent and we're going to throw in a fractional exponent. So we have to remember, what does that negative exponent mean to us? So think back to what we've done before with negative exponents. We had a rule that said if a was raised to the negative x, it should show up here shortly. If a is raised to negative x, it means that it's in the wrong spot. So we think about a raised to the negative x over 1, and it becomes 1 over a raised to the positive x. So if it's in the top, it needs to go down to the denominator. So we'll do the same thing with the 49. It's going to be 49 raised to the 1/2. Well, what does raised to the 1/2 mean? It means that it's a square root. So it's really 1 over the square root of 49, or square root of 49 is just 7. So our answer is 1/7. Okay, evaluate 32 raised to the 2/5. So at first it seems like it's going to be a pretty easy one. We can just type it into our calculator. And just a second, I'll get going here. 32 raised to the 2/5, and your calculator can show you the answer. Now, when you do this, you want to be careful that you're typing it in with parentheses if your calculator doesn't put it up as an exponent. If it does put it up as an exponent like this, 32 raised to the 2/5, then you don't need the parentheses, but it doesn't hurt to put them there. Okay, you're going to get the answer as 4. But you might, or because I know what's coming up ahead, we're going to want to break down 32 into some prime factorization. So doing a factor tree on 32, we think about what multiplies to make 32, and 8 and 4 do. 8 can be broken down to 4 and 2. 4 can be broken down to 2 and 2. Same with the other 4. And so 32 really is 2 raised to the 5th. So what I'm going to do is I'm going to rewrite that expression as 2 to the 5th raised to the 2 over 5. Because we know that 2 to the 5th is the same thing as 32, so I'm just replacing that 32 with 2 to the 5th. So now let's think about, what do we do with an exponent raised to another exponent? We had our rule that said x raised to a raised to b was x raised to a times b. So you multiply those two exponents. So what we need to do then is take 2 raised to the 5 times 2/5, which that just becomes 2. 5's cancel out there. And so our answer is just going to be 4. Okay, so our next example then is a weightlifting example. So they give us a formula, and it can be used to estimate the maximum total mass that a weightlifter of mass B in kilograms can lift using the snatch and the clean and jerk. So according to this formula, we're doing it for 168 kilograms is how much the person weighs. We can just plug that in for B, and you can just go to your calculator and type this in: 512 minus 146,230 times 168 raised to the negative 8/5. So if you type that in your calculator correctly, you should get the answer of 472 kilograms. Okay, so if you did not get that answer correctly, couple things to think about is that you do need to have those parentheses, and you do need to have a parentheses around the fraction of negative 8/5 if your calculator doesn't raise it up as an exponent right away. Okay, our next example, we've got y raised to the 1/7 times y raised to the 4/7. And so we've already talked about our rule, or have we talked about it? I'm not sure. But we have this rule, x raised to a times x raised to b equals x raised to a plus b. So you can just do that with these exponents as well. We're just going to take 1/7 plus 4/7, and they have common denominators. Hopefully you can do this in your head. Y raised to the 5/7. But because we're working with rationals, let's switch it back the other way as well. So remember, the 7 goes outside, and the 5 stays inside. The denominator goes outside, but the numerator stays inside. All right, another one. We got another negative exponent again. Okay, so we need to rewrite this as 1 over x raised to the 2/3. But now remember, if we were to rewrite that in square root form, or radical form, it would be 1 over the cubic root of x squared. Now we have a rule that you can't have radicals in the denominator, so we have to get rid of that. So rather than working with radicals, how about we just stay working with the exponents? So we need to change 2/3 into a whole number. So we need to add something. We'll add 1/3 to it, but you can't just do it there on top and bottom. Now when I say that we're adding, because remember we add the exponents, but we're technically multiplying the x's together, which will make us add the exponents. So to add this 2/3 plus 1/3, it will become 3/3, which then will no longer have a radical on the denominator. So this is going to become x to the 1/3 over x to the 3/3, or just 1. And then we could rewrite this if we wanted to as the 3 goes outside on the top, cubic root of x raised to the 1 over 1. And we don't really need, or over x, we don't really need that 1 as our exponent. Okay, our next example is going to be a little bit tougher for us. The cubic root of 16 over the, the 6th root of 16 over the cubic root of 2. And with this problem, we're going to have to do that prime factorization again. So on 16, it becomes 4 and 4, which is 2 and 2. And so that 16 is going to actually be 2 to the 4th. So let's rewrite that as the 6th root of 2 to the 4th. And then we'll just leave the denominator as it is, the cubic root of 2. And now we can change these back into fractions. So it's going to be on the top 2 raised to, think about where the exponents go. The 4 is going to be on top, and the 6 is on the bottom. And then down below, the exponent is really 1, so it's 1 over 3. Now, how do we simplify that? Let's think back to our rules. Oh, I'm sorry, we're going to reduce those first. 4/6 is 2/3, and then 1/3 just stays the same. Now, how do we reduce that? Remember, x over a divided by x over b, you subtract the exponents, a minus b. So we can do the same thing there. We're going to take 2/3 minus 1/3, and we're just going to get 1/3. And so we could write our answer like that, or we could change it into the cubic root of 2 raised to the 1. Don't really need the 1 though. Alright, our next example, the 6th root of 4x raised to the 4th. So again, we're going to want to start this out by doing some prime factorization on 4. 4 just is 2 and 2, or 2 squared. So we'll rewrite it as the 6th root of 2 squared x to the 4th. And now we can put them into exponents so that they're a little bit easier to work with. Oh, I made a mistake there. I'll erase that. So it's going to be 2 raised to 2 over 6, and then x raised to 4 over 6. Now let's reduce those down a little bit. And so it would be 2 raised to the 1/3 and x raised to the 2/3. Okay, notice how they both have 3's in the denominator, so we could write the answer like that, or they could both go inside the cubic root, 2 raised to the 1 power and x raised to the 2nd power. So that would be another way to write our answer. Alright, our last example for the day. So y to the 1/2 plus 1 over y to the 1/2 minus 1. Now remember, we can't have fractions as exponents in the denominator because basically they're square roots. So we're going to use the conjugate again. So it's going to be y to the 1/2 plus y to the 1, or plus 1, I'm sorry. And you do the same on the top and the bottom. So conjugate like we've talked about in the past. But on the top, we're going to have 2 groups in the bottom, so we're going to have to do some foiling. Let's do the top foiling first. So, first 2 is y to the 1/2 times y to the 1/2. Add those exponents together. 1/2 plus 1/2 is y to the 1 power. Outside 2, y to the 1/2 times 1 is just y to the 1/2. Inside, going to end up with the same thing. And then the last 2 is just 1 times 1, which is 1. So if we combine those center 2 terms, we can write at the top y plus 2y to the 1/2 plus 1. We just combine those 2 together there. Now we're going to have to FOIL the bottom as well. And because we did the conjugate, the outside and inside should cancel out, but the first 2 is y to the 1/2 times y to the 1/2, which is y to the 1. Outside is going to be positive 1y to the 1/2. Inside is negative 1y to the 1/2. And the last 2 is negative 1 times 1, or just negative 1. Now outside and inside did cancel out like we wanted it to, and we're left with y minus 1 for our denominator. And that is our simplified expression. Okay, that is the end of the lesson. You can go ahead and write your questions and your summaries for the lesson.